Okay, so we are now all caught up with the first week. This is the videos that started the work that we did in the second week. So the first thing we learned about were these things called characteristics of exponential functions. So exponential functions have some things about it that are always going to be the same, but then there's other things that we have to learn about it that change for each graph that we do. So when you do this on your Google form, you're going to have to answer all these questions. They may not be in the exact same order that I'm going through them right now, but you will have to do all of these parts for every graph that you look at on the form. The first question that we're going to go over is, what is the domain of f of x? So we're going to look at this function and we're going to look for the domain. Now, domain means the x values. Where does this graph exist in the range of the x values? Well, I probably shouldn't have said range because that's the next one, but where does this exist for all the x values? Now, if I look at this graph right here, we have an arrow, and this can keep going this way. So how many x values are there going to be on the negative side for this graph? All of them. It's going to go through -1, -2, -3. It's going to keep going. -100, -400. All of those values are going to be there for x's on this graph. When we look at this one and I extend it up this way, it's still moving to the right. So as it goes up, it's also moving to the right. So I see that I have an x value right here at 1. I have one at 2. I have one at 3. I have one at eventually 4. I'm going to have one x value at 10. I'll have an x value at 100. There's always going to be x values for this graph that are in the positive range. So when it asks, what is the domain of f of x? Our answer is all real numbers, okay? Or that fancy R we were talking about, it will hit every single negative and positive x value. And this is for all exponentials. So all exponential functions, I can't fit the whole word, so I'm just going to say all exponential functions, the domain will always be all real numbers. So that's how we're going to answer the domain for exponential functions. The next thing we're going to do is we're going to do the range. And the range is a little bit trickier because the range is asking us, I'm going to move that off to the side, where does this graph exist for the y values? So if I look here, notice there's this line that the graph will never go below, because as it keeps moving to the left here, it's getting pretty straight. It's never going to cross below that red line. So we have to think, what is the lowest y value on this graph? And when I do, it's going to be right here at 0, because that's where the graph is getting straight. That's where it's straightening off. Is our graph above 0 or is it below 0? It's above 0. So that means I'm going to say that all of my y values are greater than 0 because the graph is above 0. What do you think would have happened if our graph was below the red line? It would have been a less than sign because it would have been all the values that are less than that amount. Okay. Notice that there's no line underneath my greater than sign over here in part B. That's because our graph is actually never going to actually reach 0. The exponential function gets lower and lower and lower, and it gets very close to being 0, but it's never actually going to be at 0, which is why we'll never have a symbol underneath our inequality sign. It will never be greater than or equal to, and it will never be less than or equal to. It's only going to be either greater than or less than. our x-intercept. So when we look at this one over here, we see that it's getting slower and lower and lower and lower and lower. But I can't see an exact place where it hits the x-axis. This is because it won't hit the x-axis. Because the graph is straightening out right here at this line, y = 0, it's never actually going to hit any of these x values. So in this case, for the x-intercept, we're going to write none. A good trick is that if you cannot see the x-intercept, it's probably none as your answer. Because when we see an x-intercept on one of these, it's going to be really, really clear. Like in this one down here, it's going to be very clear that it crosses the x-axis. Here it's not so clear, and it does not hit it because of this line right here that we're going to talk about really soon. There's no x-intercept here. What is the y-intercept? So right here, I see a y-intercept. Come on. It's right here at 1. So I can just put the number 1, or I could put the point 0, 1, whatever you prefer. That's my y-intercept. The exponential function will always have a y-intercept. So it might not always be 1, but there's always going to be a number. There's always going to be a y-intercept for these exponential functions. This was the new vocab word that we were supposed to learn last Monday and Tuesday. It's called asymptote. Asymptote is the line where the graph gets straight, where the curve straightens out. I drew that over here in red. It's this line right here that I keep going over. And that was y = 0. So when you're writing the asymptote, it's always going to be y equals, because straight lines like that are y equals equations. And the number for the asymptote and the number for the range should be the same exact number. So with the range, it was y is greater than 0, but the asymptote is y = 0. It's where the graph gets straight. And the last part is to look at the graph and figure out if it's increasing or decreasing. When I look at this graph, and I think I need to use a highlighter because I've used so many colors on here already, and I'm starting from left to right because we read graphs just like we read books. I'm going to put my highlighter down here, and I'm going to go like this. Is my highlighter increasing or is it decreasing as I move from left to right? It's increasing. Good. So what we're going to say, if it loads, I want to change to a pen. Did it really freeze? Okay, it's back. Okay, what I'm going to say is I'm going to say that this is increasing. And this is just something we say for exponentials afterwards, is over the entire domain. Because that means that it's increasing forever. It's always moving in the upward direction. The exponential functions will always have the phrase over the entire domain after the word increasing or decreasing. Let's do one more example before you guys have to try some on your own. And this one is a little bit different because of the fact that this one was going up, that one's going down, and some of the other features are a little bit different than the first one. So our first step is to look at this and try to figure out what the domain is going to be. And like we said in the first one, when we're looking at domain, we're looking at our x values. So as this goes up, it's also still moving to the left. So I'll have a value at -2, -4, -5, -6, -100, -400. I'm going to hit all of those x values. Same thing here. As this is moving down, it's also moving to the right a little bit each time. So I'll have a value at 1, 2, 3. I'll have a value at 400. I'm going to have all of the values of x at some point within this graph. So for my domain, like I said in the first problem, it's all real numbers. And we already talked about, for an exponential function, your domain is always all real numbers. Okay, the range. They were nice and they gave us the dotted line here. We didn't have to draw it in. But if they don't put a line on that graph, you want to go through and you want to put a line where the graph gets straight, where it straightens out, because that's going to help you with the range. So we said y, and we have 5, because that's where it gets straight. If I look at the graph correctly, right here, I see the dotted line go through 5. Now I have to think about my symbol. Is this exponential function drawn above the line or below the line? Below, so it's less than. So I have y is less than 5. So my x-intercept, I have to estimate this a little bit. I'm going to say maybe like 2.3. I'm going to say about 2.3. If I wanted to write it as a point, I'd say 2.3 comma 0. Because we can see this one hit. I'm going to just put the number. What's the y-intercept? I see it right here. That's at 4. I'm going to say 4, or I can say the point 0 comma 4. The asymptote, like we said in the first problem, is where the graph straightens out. They drew in our dotted line for us here, but if we don't have that, we have to figure out where it straightens out on the graph. And say y equals 5. And I know I'm right because this and this match. The range has the same number as the asymptote. And then I need to think about this graph and see if it's increasing or decreasing. As I move from left to right, my pen goes down. So that means that my graph is decreasing. And then we say over the entire domain, because in an exponential function, it's either always going to be increasing or it's always going to be domain. It's always either going to be increasing or always decreasing. So we need that second part there, that over the entire domain. Okay, so that was characteristics of exponential functions. If you're still stuck with that topic, make sure you reach out to one of your teachers and we can help you further before you complete that section. Talk to you soon.